this episode, we focus on what turns artificial intelligence, AI, from an exciting experiment into a capability an organization can safely rely on: governance. Governance is not a single document, and it is not a committee meeting that happens once and then disappears, because AI systems keep producing outputs every day, and those outputs influence real decisions. Beginners sometimes hear governance and assume it means slowing everything down, but good governance is actually how you move faster with fewer surprises. It sets clear boundaries on what is allowed, who is allowed to do it, and how the organization will detect trouble early. When governance is missing, employees make their own rules, sensitive data gets handled casually, and leaders learn about problems only after damage is done. When governance is present, people know what safe use looks like, systems enforce boundaries automatically, and monitoring provides early warning when something drifts or is abused. The title highlights three parts that must work together: acceptable use, access controls, and monitoring expectations, because policies without enforcement are weak, enforcement without clarity is unfair, and monitoring without action is just watching. A good way to understand acceptable use is to treat it as the organization's shared definition of safe and unsafe behavior with AI, written in language that normal employees can actually follow. Acceptable use is not just about forbidding obvious bad things. It is about guiding day-to-day choices, like what kinds of data can be entered, what kinds of tasks are appropriate, and what kinds of outputs require verification. Beginners often assume the main danger is malicious actors, but the most common failures come from well-intentioned people trying to be efficient. If someone pastes sensitive information into an AI tool to get help writing an email, they may not realize they are creating a data exposure risk. If someone uses an AI output as a final answer for a policy or a customer response without checking it, they may not realize they are spreading confident errors. Acceptable use should be specific about these patterns, including examples of what counts as sensitive information in the organization's world and what kinds of work require human review. The most effective policies also include a simple rule of thumb for uncertainty, such as when you do not know whether information is allowed, treat it as not allowed until you confirm. Acceptable use also needs to define the allowed purposes of AI, so the organization does not accidentally grant permission for high-risk activities through vague language. There is a big difference between using AI to draft internal notes and using AI to decide who gets access to a system, and governance must recognize that difference. A beginner-friendly way to frame this is to separate assistive use from decision-making use and from automated action. Assistive use means AI helps a person create or organize information, while the person remains responsible for correctness and judgment. Decision-making use means AI outputs influence a decision, such as recommending a risk rating or proposing a response, which raises the need for documented verification. Automated action means AI outputs can trigger changes, such as opening an account or routing a request, which raises the need for strong constraints, logging, and rollback capability. Acceptable use should specify which categories are allowed today and under what conditions, because otherwise teams will drift toward the most convenient and risky applications. Beginners should notice that if the policy never mentions automation, someone will still try it, because convenience creates pressure. Good governance anticipates that pressure and provides safe pathways rather than pretending it will not happen. The next part of governance is access controls, which is the practical mechanism that enforces who can use AI systems and what those systems can access. Access controls are essential because not every user should have the same privileges, and not every AI feature should be available to everyone by default. For example, access to AI tools that connect to internal documents should be limited to the users who are already authorized to see those documents, and the AI system should not become a shortcut around existing permissions. Beginners often assume that if the tool is internal, it is safe, but internal systems can still leak data if access boundaries are weak or if logs are too broad. Access controls also apply to configuration rights, such as who can connect the AI system to new data sources, who can change how it behaves, and who can enable tool-like capabilities that make the system more powerful. A good governance approach requires that these high-impact changes are visible, reviewed, and traceable, because configuration is where many hidden risks originate. This is the same logic used in other security domains, the ability to change security-relevant settings should be treated as a privileged capability. A crucial access control concept for AI governance is least privilege, meaning each user and each integration should have only the access needed to perform the approved task. This matters because AI systems are good at combining information, and that combination can accidentally reveal more than intended. If an AI tool is allowed to retrieve broad internal knowledge, a user might ask an innocent question and still receive content that should not have been shared with them. Beginners should recognize that this kind of leakage can happen without any malicious intent, simply because the system is doing its job of being helpful. Least privilege also applies to data retention and conversation storage, because if conversation history is stored and broadly accessible, private information can spread beyond the original interaction. Governance should define who can view stored prompts and outputs, how long they are retained, and under what conditions they can be accessed for troubleshooting. Access controls should also cover third-party connections, because when AI tools connect outward, the boundary of trust expands. Even when the organization does not name a vendor, the governance idea remains the same. Any external connection changes the risk profile and must be controlled. When least privilege is applied consistently, the organization reduces the blast radius of mistakes and reduces the incentives for misuse. Access controls also need to cover the concept of identity assurance, meaning how confident the organization is about who is using the AI tool and whether that identity is genuine. Beginners may not realize that if an AI system is widely available, it can become a target for account misuse, because the tool might provide access to sensitive content or might generate persuasive messages that help attackers. Strong authentication and careful session management matter here, not because AI is special, but because AI can amplify impact. Governance should require that access to sensitive AI capabilities uses stronger identity checks and that privileged actions, like connecting data sources or enabling automation, require extra assurance and approval. Another important point is separating duties, meaning the same person should not always have end-to-end control over sensitive capabilities without oversight. If one user can both connect the tool to sensitive data and approve its use in high-impact workflows, mistakes or abuse become harder to detect. Beginners should see that governance is about reducing single points of failure, both technical and human. Access controls, when designed well, create healthy friction only where risk is high, while leaving low-risk use cases easy and productive. Monitoring expectations are the third pillar, and they are what make governance real over time rather than just real on launch day. Monitoring is not only about watching for attackers, because AI systems can fail through ordinary drift and misuse that looks like normal usage. Monitoring expectations should define what signals will be collected, who will review them, what patterns are considered suspicious, and what actions will occur when those patterns appear. Beginners should notice that monitoring has two purposes: security monitoring, which looks for abuse and data leakage attempts, and performance monitoring, which looks for quality degradation, bias shifts, and unexpected failure modes. If you only monitor for security threats, you might miss the slow decline of usefulness that causes users to work around the tool in unsafe ways. If you only monitor for quality, you might miss a pattern of misuse where someone is probing for sensitive information. Governance must require both, because AI systems sit at the intersection of data, behavior, and decision-making. Monitoring also needs to be designed with privacy in mind, because over-collecting sensitive content and logs can create the very leakage risk you are trying to prevent. The expectation should be to collect enough to investigate and improve safely, without turning monitoring into a new vault of sensitive text that everyone can browse. A practical monitoring expectation is to treat prompts and outputs as potentially sensitive and to design logging so it supports investigation without copying secrets everywhere. Beginners often assume logging everything is the safest approach, but in AI systems, logging everything can become a data exposure hazard. Governance should clarify what is logged, such as metadata about usage patterns, and what is not logged, such as full content unless necessary for a specific reason. It should also define how sensitive elements are protected, including access restrictions and retention limits. Another key monitoring expectation is anomaly detection on usage, such as unusual spikes in queries, repeated attempts to elicit restricted information, or unusual access to sensitive sources. This is where security operations thinking applies directly. If you can see patterns, you can respond early. Monitoring expectations should also include review cadence, because collecting signals without reviewing them is a false sense of safety. Beginners should understand that the best monitoring is boring monitoring, meaning it runs reliably, triggers rarely, and produces actionable alerts when it triggers. Governance must therefore define thresholds, escalation paths, and ownership, so monitoring results lead to action rather than to ignored dashboards. This is how monitoring becomes a control, not a decoration. Governance also needs to address the model lifecycle, even at a high level, because AI systems change over time in ways that traditional software does not. A model might be updated, retrained, or replaced, and each change can affect output behavior, risk, and performance. Beginners should understand that model changes can introduce new failure modes even when improvements are intended, because patterns that worked before might be interpreted differently after an update. Governance should therefore require change management for model updates, including testing against representative tasks, evaluating performance metrics, and documenting known limitations. It should also require a rollback plan, because the ability to revert is a safety requirement when a system influences decisions. Another lifecycle concern is drift, where performance degrades because real-world inputs change, such as new business processes, new vocabulary, or new data distributions. Monitoring expectations should include drift detection and a plan for responding, such as retraining, adjusting prompts, or narrowing scope. Leaders who assume an AI system is stable once deployed will govern it poorly, because stability must be verified continuously. Governance is the discipline that treats change as normal and plans for it. Another area governance must cover is how humans interact with AI outputs, because many of the highest impact failures come from overtrust. AI outputs can sound confident and coherent even when they are wrong, and that creates a psychological risk that is different from typical software errors. Acceptable use should require human review for high-impact use cases, but governance must also define what good review looks like, because review that is rushed or symbolic does not reduce risk. Beginners should understand that verification is easier when outputs are grounded in sources or when the system provides references, but many generative systems do not naturally provide trustworthy grounding. Governance can require that certain use cases include source validation, or that outputs be treated as drafts rather than as final answers. It can also require training that teaches users what the system can and cannot do, especially the idea that fluent text is not proof of correctness. Another human factor is prompt behavior, because users will adapt and may try to push the tool into tasks outside its safe scope if they believe it will save time. Governance should anticipate this by providing safe alternatives and clear escalation paths for when users need capabilities beyond what is approved. Managing human trust is part of governance because trust influences behavior, and behavior creates risk. A practical governance framework also needs clear accountability, because shared ownership does not mean nobody owns anything. Governance should define who owns acceptable use policy, who owns access control configuration, who owns monitoring operations, and who owns incident response when something goes wrong. Beginners should notice that if ownership is unclear, every issue becomes a debate about responsibility, and debates cause delays during incidents. Accountability also includes who can approve exceptions and under what conditions, because exceptions will be requested when business pressure rises. A mature approach allows exceptions only with documented rationale, defined duration, and explicit compensating controls, such as additional monitoring or reduced scope. This prevents exception drift, where temporary allowances become permanent holes. Governance should also define how issues are escalated, such as when a suspected leakage event triggers a security investigation or when model drift triggers a pause in use for certain workflows. These escalation expectations should be tested in practice, because plans that have never been exercised tend to fail under stress. When accountability is clear, governance becomes a living system of decisions and actions rather than a static policy binder. It is also important to understand that governance must be proportional to risk, because a one-size approach either slows harmless use cases or fails to control dangerous ones. Beginners should recognize that using AI to help with brainstorming internal meeting notes is not the same as using AI to generate customer-facing legal advice or to drive security incident decisions. Governance should therefore classify use cases and apply stricter controls to higher-risk categories, such as requiring stronger access controls, more robust monitoring, and mandatory human review. This proportional approach makes governance feel fair, which increases compliance, because teams are more willing to follow rules that match the risk they can see. Proportional governance also supports innovation, because it creates safe zones where experimentation can occur without exposing the organization to unacceptable risk. For example, a limited pilot with synthetic data and strict boundaries can be a safe way to explore value. As confidence grows, governance can expand scope responsibly, using measurable evidence rather than optimism. Beginners should see that this is how organizations avoid swinging between reckless adoption and total prohibition. Good governance is flexible in the right ways and strict in the right places. Incident readiness is another governance requirement that leaders must not skip because AI introduces new kinds of security and safety incidents. A leakage event might involve sensitive prompts being exposed. A prompt abuse event might involve attempted bypass of restrictions, and a misuse event might involve the tool being used for harmful communications. Governance should define how to detect these events, who investigates, what immediate containment actions exist, and how the organization learns afterward. Beginners should understand that containment in AI context often involves disabling specific integrations, reducing access privileges, tightening monitoring thresholds, or temporarily restricting certain use cases. Governance should also require post-incident review that updates policies, controls, and training, because repeated incidents often indicate systemic gaps. Another important aspect is communication, because if AI affects customers or employees, trust can be harmed quickly if leaders cannot explain what happened and what changed. This does not mean public statements in every case, but it does mean internal clarity and responsible reporting paths. Incident readiness turns governance into resilience, because it assumes failures will occur and plans for rapid response. Leaders who plan only for success are building fragile systems. When you step back, setting AI governance is about turning a powerful capability into a controlled, accountable, and observable part of the organization's operations. Acceptable use sets clear boundaries on what tasks are allowed, what data is permitted, and what human verification is required, so people are not forced to guess under pressure. Access controls enforce those boundaries by applying least privilege, protecting sensitive integrations, controlling configuration rights, and ensuring identity assurance matches risk. Monitoring expectations make governance durable by defining what signals are collected, how they are reviewed, and how the organization responds to both abuse and drift, while avoiding the trap of creating new data exposure through excessive logging. Governance also covers lifecycle change management, human trust behaviors, proportional control based on use case risk, and incident readiness with clear accountability. For a beginner, the most important takeaway is that governance is not anti-innovation, because it is the system that allows innovation to scale safely without constant surprises. When acceptable use is clear, access is controlled, and monitoring is meaningful, leaders can approve AI use with confidence because the organization can see what is happening, enforce what matters, and correct problems before they become crises.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.